Check, check. Really?
Yeah, we need to sit and talk, but I have such limited time that we might need to go on the Discord.
Okay. 12:30 to 1 or not?
12:30 to 1 might work. Depends on
If it works, come. If it doesn't work, Discord, we'll figure it out. Hey, Mike. Do you mind playing cameraman? Mitch usually does it, but he's not here right now.
Is it live?
Yeah. Yeah, so don't talk about anybody behind their back. Good morning. Good morning. I know. Good morning. I'm Tony Farrar from the Mechanical Engineering Department, and I absolutely love to automate boring tasks with loops. Today's going to be an extra special day. We have a guest to wind us up with another example of what students can do with code. And after that, we will get into arrays and loops today, which you'll find very helpful for Friday's code sprint. So let me please welcome Nigel, from Pinpointer, a current student here at Temple who does interesting things with code. So all you got to do is click these both on, and then you should be able to talk just fine. And
my fine motor skills are not the best.
And then the clicker does work. So
Okay.
at least it did a minute ago. Thanks for dealing with all the gizmos.
Oh yeah, no problem. All right. Hello, everyone.
Hello.
My name is Nigel Sattenstein. I am a senior business student here at Temple. I'm here to talk today about my company Pinpointer, which I started 2 summers ago with 2 of my friends that go to University of Maryland. So what is the problem that we are solving? So it all started the summer after my sophomore year. My friend Eric, who I went to high school with, called me up just out of the blue and was like, yeah, so my roommate is from Nepal, and he says that they don't have any addressing infrastructure there. So it's like, what? That's crazy. What does that even mean? So basically, they have like almost no street signs, and none of the buildings are marked. So that's been a big problem for them with trying to get e-commerce going. You know, we've all seen how much Amazon has grown over the past decade, and like how huge e-commerce has become in our society. So that's something that has really been stifled there. So say you want to order something online in Nepal, where my co-founder Sam is from. You would go online, go to the checkout like normal, and basically what would pop up is a big paragraph text box. So you would enter a landmark near your house, a school, a hospital, a statue, something that a delivery person with local knowledge of the city would know, and then you manually fill out that text box with turn-by-turn directions from that landmark to your doorstep. So basically it would be like, leave the statue, go up the hill, take a right at the apple cart, past 3 trees, it's the second black door on the left. So as you can see, it's like definitely super inefficient, and it's a huge barrier for people ordering online. Often the delivery person can't find their house, so they end up calling the person, and they just end up having to walk to the landmark. So it's really super inconvenient. So this is something we kind of take for granted here. You know, emergency services can find you, respond to your call in 5 minutes. You can get food delivered to you in about 30 minutes. And you can get pretty much any item you can imagine shipped to you across the country within 2 days. So this addressing problem is not limited just to Nepal, where my co-founder is from. There are actually 4 billion people worldwide that do not have addresses throughout South America, the Middle East, Africa, Southeast Asia, the Caribbean. So yeah, it's definitely a huge problem. So we decided to try to solve this problem. My 2 co-founders are electrical engineers at Maryland. I kind of do all of the business stuff, even though I've been learning to program myself. But yeah, so we started brainstorming ideas, and what we came up with is a 2-sided application. One side that is user-facing for the end consumer that's actually buying the goods online, and the other is an enterprise solution that helps facilitate the deliveries for online retailers and delivery couriers, and basically to just make it as easy as possible to make that transaction with their customers. So on the user side, it's really simple. So you just download the app, and then it'll use your longitude and latitude, and instead of using that long string of numbers, you can rename it your like pinpoint or hotspot to whatever you want. So like I could download the app, name it Nigel's house, and then I'm good to go from there. So once you do that, you take your phone, walk outside to the landmark that you normally would put in at checkout, and it leaves what we like to call our virtual breadcrumb path. So that basically just traces from your doorstep to that landmark. So you do that one time, and that virtual breadcrumb path is then saved on our servers and will be used on the enterprise side to help facilitate the delivery. So this is kind of what it looks like for the delivery person. So basically, what they'll do is they'll navigate to the landmark using their local knowledge of the city. When they arrive to the landmark, the breadcrumb path will be unlocked, and they'll be able to retrace it right to your doorstep, and you won't have to leave your house. So this is actually the first time that last mile delivery is happening in a lot of these developing countries. So another way that we add value to our retailers, who are our customers, like those are the people paying us, we also will go in and automate and optimize their delivery routes. So we'll take all their orders that they have for the day and basically map out the quickest route that they can go around. So we're saving these retailers a lot of time and energy and manpower going around. So they've been able to cut down on the amount of delivery people that they need. Definitely increased amounts of deliveries are made every day. So it's just whatever we can do to make that process as seamless as possible, which is something that we definitely take for granted here. So as I was talking about before, this is what it looks like now, a checkout screen if you want to order something online there. So you fill out that landmark box and then that big paragraph text box. So now with the Pinpointer plugin, all you have to do is enter the name of your Pinpointer code and your passport or password, and then you are good to go. So our target market, we chose to start in Kathmandu, Nepal, just because that's where my co-founder is from, and he wants to see that impact made on the ground there. So our strategy to acquire customers, because we knew that that was going to be like a very crucial aspect. So we started out targeting universities and non-governmental organizations. So the main NGO that we're working with now is a chain of Nepalese orphanages. I think there are 14 of them, called NAFA. And so basically how it was working before is their nurses were having to rent a rickshaw and go down to the city, like down into the city and like pick up their food and medicine and clothing supplies each week. So that was taking their time away from like actually caring for these kids. So basically what we've done now is they're testing our service, and it's allowing all these things to be delivered right to them, allowing them more time to care for these kids. Another way that we've been working to introduce people to Pinpointer is there's a university called Tribhuvan University that has about 400,000 students in Nepal. So we're organizing a demo where we're delivering their semester report cards using Pinpointer. So we chose this method because these university students are most likely to be the early adopters. Most of them all have smartphones. And then we're leveraging that into a partnership with a textbook dealer there. So after all these 400,000 people have been introduced to the service, we'll then follow up and show them something that they need and can order online. This is just a map to illustrate all of the places where this addressing problem exists. So as you can see, it's a pretty large part of the world, about 4 billion people. That's our team. And that's it. We'll talk about, I didn't put a slide in, but I'll talk a little bit about our revenue model as well, because that is very important. So we kind of looked throughout the industry when we were trying to decide our revenue model, and we settled on kind of emulating PayPal's model. So basically what we do is charge 2.5% of each transaction to our retailers. And we justify this because we're bringing down their cost of employing delivery people, automating their current manual processes, and also expanding the scope and frequency of orders by making it more convenient for the end consumers. Thank you.
So we got time for a couple questions if anybody wants to ask.
Have you been to Nepal to see how it works?
Yeah, so I have not, but last week me and my co-founder booked tickets to Nepal and India, so we're going in May. When we tried to test out the enterprise version last summer, we realized that it was really hard to do remotely far away. So we took away some learning lessons from that, and we're now regrouping, coming back with our second version, and we're going to test it on the ground there. Yeah.
Is there a way for someone to use this app if they have no cell phone service at all?
Yeah, so the question was, is there a way for people to use this app with no cell phone service at all? So you can create your hotspot with just a computer. The really interesting thing about the markets that we're mostly targeting, So right now, like the main markets we're targeting at first are Nepal, India, and Kenya. And what's really interesting about these developing countries is they've almost bypassed like the desktop computer phase altogether. Like they've gone to like having nothing to like having smartphones. So the biggest problem isn't even them having smartphones. It's that like, is the internet strong enough to like do these things? But we actually built it so you don't need to be like actively on the internet to leave the pinpoint or breadcrumb trail. You can like turn that off and it'll like save it, and then when you get back with internet access, then it'll upload it to the servers. So that's kind of how we worked around that. But yeah, obviously that's one of the biggest challenges for us.
Maybe time for one more.
So, how long did it take you to like start this up, and like how long do you think it'll take you to go, I would say like globally, to a point where you're almost every country?
Sure. So the question was, how long did this take us to start up, and how long do we think it'll take for us to grow globally? So like I said, I started this the summer before my junior year. One of the ways that we were able to gain traction early was just by getting involved at Temple. I was in the Innovative Idea Competition, which is open to all students. Last year, won that, so then we had like a little bit of seed money. I think we won like $4,000. So like getting started was kind of a slow process because like we actually needed to build this platform, but luckily my co-founders are pretty tech savvy, so they were able to help with that. But getting help from Temple was like super easy and very helpful. As to how long it'll take for us to grow, I think this is like the type of solution that could be implemented for years and years to come, just because of the scale of the problem and how fragmented these different markets are. Like they're addressing infrastructures aren't all exactly the same. So there's unique challenges in each market that we have to deal with. So we've been trying to like figure out what's the best way to move forward with that.
All right. Hey, well, thanks again. I really appreciate you coming and sharing your story with
Yeah.
us here. Never too early to start. Thanks again. Thank you so much. So why are we teaching you how to program? Thank you. Because it's fun. Why else? So we can solve problems. What kind of problems? Worldwide problems. I absolutely believe that there are a massive number of issues facing our world that can be solved via software. And we are just starting to pick at what those are and ways that we can be a part of fixing them. The clicker works today. That's exciting. Now I don't have to stand back here and hide from you. We bring those stories in for you as often as we can as a way to let you know that this isn't just something for the unobtainable founders of Facebook and large crazy enterprises, but that right from among our student population, we right now have people starting and succeeding with software-based companies. Today we're talking about arrays and loops. After just a little bit of housekeeping, one thing, please again, use your TU email address for your assignments. If you don't, it throws a wrench in our somewhat now robust grading software that we've written. The result will be that your grade will be delayed and you won't know how you're doing. And I don't want to do that to you. So please use this email address. Here's the update on where we're at on JavaScript. As of a week ago, you were supposed to be done with 3 of them. 70% of the people in the class were, so I'm pretty excited about that. This week, You're supposed to have completed 6 of the 10 assignments, and we've dipped almost 10% in our completion rate. So that means that 60% of us are on track and 40% of us have a little bit of catching up to do. It is by far nowhere near too late, but every day that you delay makes this catch up a little bit more painful. So if you're stuck, if you're having trouble, if you haven't started for whatever reason, we are upstairs to help you. Please take advantage of that. We have a pretty vibrant community forming up there of people who are already coming up with interesting ideas, developing solutions, and above all, getting through these coding assignments in a lot less time than the people who are doing it by themselves. So please come join us. The story so far was in week 1, we talked about the fact that our new economy requires others-mindedness. We're in the business of solving problems, and not just any problems, but problems that people need solved. We then started in on the interesting observation that computers are actually fairly stupid. They don't know how to do anything that we don't tell them to, even when the thing that we tell them to is the wrong thing. I'm famous for that, asking the wrong question. What we're going to talk about now, these next few weeks, is therefore let us teach them how to do good things. And so we started in on that by trying to get the basic idea of human needs. This is your mission, our mission. Identify human needs, meet them with code, find ways that we can solve these problems. And we just started to put these bins. Next week we're going to spend a full day in class together really picking at this and identifying some problems that your company is interested in solving so that you can start to collaboratively define, that's a big word, what it is that you're going to do for this semester as a project. So I encourage you to come. I encourage you to participate in that, lest your fate be decided by someone else. So, what do computers do? They take things like this input, they crunch them through the magical black box, and they give us some output. And that's what we're in the business of dealing with, creating the black box. One of the more interesting ways that we do that is through a data type called an array. And these show up in just about every language in different ways, and I'd like to show you why they matter. Imagine we go to the grocery store. I'm walking around my house first, and I'm noticing all of the things that I don't currently have. Maybe I need chocolate. Of course I need chocolate. And milk, and eggs, and cheese, and chips, and all these different things that we're out of. And if you put all of those into one dish, it's going to be weird. So I take them all, and I write them on a piece of paper, and I go to the grocery store. The question that I'd like to ask is, if I were writing a grocery list app, how could I store all of these items on my list? Well, one way that I could do that is that I could create some variables, and I could cram one of these items into each variable. Right? And so I've got 10 items. We start counting from 0 in here, and so I've got 0 through 9 variables. Each one holds one item. What's a problem with this? Yeah.
Well, say you're using this and you're trying to market to a wholesale grocer.
Uh-huh.
You're going to have varied onions, varied milk, varied...
Okay, so one issue is if I was marketing to a larger customer, maybe I'm actually trying to sell an app that stores these things for a grocery store. Maybe they've got lots of different varieties of these things, right? And so now I need a bigger list, right? In fact, if I was trying to do this for a grocery store, I'd have to create probably tens of thousands of variables. What else? Yeah?
It's not efficient and it's a lot of variables.
It's not efficient. It's not very easy to deal with the variables. I have to constantly remember what I stuck in item 3. What happens if I had 11 items? Or 6? What happens? Yeah. Right, I have to change the code. I'd have to actually open up the code itself and edit it. And then if I wanted to look at them one by one, I'd have to do something like this. So variables like that are kind of a pain to deal with. The idea of an array fixes that. What an array is it's a larger variable type that we can take all of these items and stick into a single variable with a single name. And so now what we could do is we could have some code that says something like create, let's find out how many items we want to store, and then create a variable called cart that has however many boxes we need for the number of items that we're going to shop for. And then from there, we can go through and actually populate each item, bang, bang, bang. And it turns out that you've done this before. If you've ever had to make a table in one of the Office products like Excel or in PowerPoint or Word, you can do this. This is a 1D array. We have a one-dimensional array with 10 elements in it. What's missing? I'm sorry? Somebody muttered. No? If I actually wanted to go to the grocery store with this, what would happen? Yeah. I'd need something to store it. What do you mean? Like a device or something, or? Okay. So it needs to have a name. So maybe this word cart here is with an equal sign next to a thing that defines this variable. The number one mistake that I make when I go to the grocery store is not coming back with enough. How many eggs do I need? How much chicken do I need? So the 1D array is interesting, but it can only store one kind of category of data. Wouldn't it be nice if we could store more information? Like how many bananas I want? Sure. We just make ourselves a multi-dimensional array. So now instead of creating an array that has 10 elements in 10 rows, I create an array that has 20 elements, 10 rows, 2 columns. And now I could populate that with the quantities for each item that I want to go buy. And so now we could create ourselves a 2D array with n elements. So here's 10 elements by 2, n by 2. And then we could go down each column and fill them in with items. And you've done this before too, right? Because we can make a 2 by 8 table in all these apps just as well as we could a 1 by. We would refer to this now as a 2-dimensional array because it has rows and columns. And so it has 10 by 2 elements or 20 total elements. Are we done? Some say, I wish we were. What other information might I care about? Units? Yeah, units would be an interesting one, right? Do I mean 12 eggs or do I mean 12 cartons of eggs? 1 stalk of celery, 1 pound of celery? Other things we might care about could be cost, could be the department that it comes from in the store, whether or not it needs to be in the refrigerator. So I could just make my array bigger by adding more and more columns. So, is this a 1D array? Bueller? 1D array? No. Is it a 2D array? No. I see some no's. Anybody say yes? How many dimensions is you say yes? Why? Because it still just has 2 dimensions, 2 directions it goes. It still just has rows and columns. So it's still 2D, just like this is a 1D array if it was just this one column, right? It's a 1D array of 10 rows. This is a 2D array of 10 rows and now 1, 2, 3, 4, 5 columns. And so we could go through and we could fill all these pieces of information in. And now we get another interesting question. What's the best order to store this in? How should I organize my list? I'm sorry? By department. When would I want it to be organized by department? When I'm in the store, right? If I go to the store, the most efficient way to sort this, would be, come on animation, do your job, to sort it by department, right? Produce, dairy, that way I'm not ping-ponging back and forth around the store, which is what I usually end up doing. Is that the only way to store it? What's another way to store it? Whether or not it needs refrigerated. So I got that out of order on you. You beat me, but we'll get there. Is there any reason why I'd want to store these things alphabetically? Some say no, some say yes. Let's go back to your use of having this be for a store. Now imagine that you're at the customer support desk and somebody comes up and says, do you sell onions? What would be the most efficient way to store this to answer that question? Alphabetized, right? Because the easiest way we could find onions now is to go up and down the list until we find onions, and if they're just in some random alphabetical order, that wouldn't work out for us. And then the last one you came up with was refrigerator. Not lots of reasons. Maybe we're going on a camping trip. Maybe it's for disaster relief. The power just went out, and we've got to figure out which items we need to wrap up and which ones we don't. And so we might want to store this by whether or not they're refrigerated. And so there's a really interesting thing that comes up here, which is that we actually organize our information according to the way that we're going to use it. So how do we access it? I want to find out what is in this box of my array. Yeah? I'm sorry? Exactly, right? This is element 0. In fact, there's all the element names. And I can now ask for one of them. We use hard braces in JavaScript. So if I go cart of 0, assuming that this is what's stored in cart, what's it going to throw at me? Bananas. How about if I do cart of 3? Cheese, 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 cheese. Okay, we'll take the picture. And one more, I think. Cart of 8. Milk. Okay, so that worked pretty good. We can read them. So now I could bury this in a console.log, right? I could say console.log cart of 0, and it would print the word bananas. I could do this in an alert box. I could do all kinds of interesting things with this. What if I wanted to stick a new item in? What if I wanted to replace bananas? What changes? I'm sorry? Right? We just need to let it equal something else. And so just like assigning an individual value to a variable, we can assign an individual value to one element of array just by adding the equal sign. So if I type cart of 0 equals grapes, it will get rid of the word bananas and replace it with the word grapes. Ditto if I say cart 3 equals pretzels. We can get rid of the cheese and get pretzels. Already our meal is getting healthier, I guess. And cart of 8 instead of milk, let's get cream. And that one goes away too. And so we can do this element by element just like so. And so I can imagine now, if I wanted to, I could write an app that says, hey user, type in an item you want. And we could just start logging them one by one right down this list. We can do it for a 2D array too. We just need 2 addresses, right? We need a row and we need a column. And so now, where's eggs sitting? Mumble, mumble. I heard it. 0, 0. Cart 0, 0. Row 0, column 0 says eggs. How about cart 3, 2? What's in cart 3, 2? Huh? Meat. That's that one. Row 3, column 2. So the notation I'm using here is row, then column. And this works for assignments as well. If I wanted to replace row 9, column 3, that would be the price of crackers. We're going to put them on sale for $2.50. We could come right over here, and with this equal sign added to our expression, we can get rid of the $3.99 and drop a $2.50 in there. All things that you can do with arrays. So there's a 2D array. The fun thing, though, is that arrays don't just work for that kind of data. Other things that are actually stored as arrays include pictures. In fact, we can use an array like this to define a black and white picture. So this is a, I believe, 20 by 20, maybe 16 by 16 array. And everywhere that it has a 0 in it, I treat as a black pixel or a white pixel. And everywhere that I have a 1, I give it a black pixel. And that's how black and white images on your computer work. This is how 8-bit games work. Or if we had a really, really big array, we could start to make this look pretty nice. And I made a toy for you. I'll post this today. There's a trick in Excel called conditional formatting. and you can pick a color scheme here, and you just type in ones and zeros, and it will print, or it'll change the color of the cells for you. And we have a whole bunch of fun samples in there for you now, like the TU logo and all of that. I'll post it up there with our stuff today. But we can do better. Does anybody know how color works? Well, now you do, right? RGB. In a computer, we actually set the color value of a pixel using its RGB values. We have a value for red, we have a value for green, and we have a value for blue. And so on 256 colors, we can go from 0 to 255 in red intensity. We can go from 0 to 255 in green intensity and 0 to 255 in blue intensity. And thanks to the way that colors combine, if we add these together, we can get just about any color we want. Any guesses on how I get white? All of them at 255. Right? 255, all the red, all the green, all the blue comes out white. Let's try a different color. What do you think this one looks like? This has a little bit of red, more green, but kind of a mid-range green, so it's kind of dim, and a little bit of blue. What are you going to get? All right, starts to get a little weird, right? It turns out to be this kind of olive drab army green. All right, we'll try another one. This one is lots of red and blue. What do red and blue make? Purple, but I'm going to lighten it up with some green. Pinkish, fuchsia, magenta, magneto. What about grayscale? Well, the way grayscale works, it's just three of the same, right? If white was 250, 250, 250, we could have 140 be some gray or some 40 be almost black. So what if we wanted to take a color picture and make it black and white? What could we do? All zeros and all ones, right? Or in this case, zeros and 256s. Now what if we wanted to make it grayscale, where it ranged in brightness now, so we could have different shades of gray? Well, the basic idea is that we could get the RGB value of every pixel, do some sort of fancy math that converts those RGBs into a single value for a gray, for a shade of gray, and then replace the original RGB values with that new gray one. Any theories on some ways we could do fancy math? Yeah?
You could try adding all RGB values and dividing by 3.
Add them all and divide by 3, also known as the average, right? And so we could do red plus green plus blue divide by 3 for every cell or every pixel, and now we would get something on our gray spectrum. So for example, if we wanted to do this one, we would take 255 plus 255 plus 255, divide by 3. What are we going to get, everybody? 255. Yay. Okay, we'll try a little bit harder one. Here's this greenish thing again. Right, so now we're going to take 37, 140, 39, add those together and divide by 3. It gives us a value of 72, which 72 looks like that on the grayscale if we take and put equal amounts of red, green, and blue in. And we can do this for the fuchsia color. 209 plus 37 plus 197 over 3 is 148. And so we get something that looks like that, almost a light gray now instead of a darker gray. We could get these all on one screen so you can see. So we took white, stayed white. This greenish kind of became a darker color, and this fuchsia kind of became a lighter color, which may or may not make sense to your eyeballs, but that's the math. Let's make it harder. So now I have this colorful picture of 655 by 1920 pixels. So how big is my 2D array for red? It's not a trick question. Yeah. Right, so we got 655 rows, 1920 columns, and every one of them has a value between 0 and 255 for red. We have a second one of those for green and a third one of those for blue. Let's just look at this little spot and actually we're going to look at a spot within that spot because otherwise we wouldn't be able to get the whole thing on one slide. Bang! So this is one little region of our thing, so there would be more rows in the red and more columns in the red as well. And we got red, green, blue values. If we wanted to convert this to grayscale, we could take the 142 here, the 121 there, and the 120 here. Those three values go together. Those are the three values for 1 pixel, the RGB values. We could add them up, divide by 3, get ourselves a new value of 126, and replace them. How's that? Do you think, by the way, that, don't push that button. Do you think that if I take those three values, add them up, and divide by 3, or multiply by 0.33, that I got exactly 126? Right, we got to round this thing to a nearest integer. Right, ceiling 4 are a couple of options for that. But then we do this again, right? 140 plus 120 plus 119, divide by 3 gives us 125, so there's those, and so on and so forth. And we could go pixel by pixel through all these arrays and get ourselves a grayscale image that would look something like that. And without giving too much away, this is going to be your problem on Friday. We're going to write a color converter for a picture to go from color to grayscale. What would be really weird is if we could come up with math that did the opposite of that. Right? What if we added color back? Ooh, weird. So, fun things. If you did fancier math than just adding them and divided by 3, what you would arrive at are all of the Instagram filters. It's the exact same thing. It's just maybe we do a different version of the averaging. Or maybe based on where you are in the image, you do different values, distance from the edge, right? If we want that, like, what's that, lens flare effect or whatever it is. What if we wanted to make videos? What's a video? Well, it's just a bunch of pictures, one image at a time. And so we could take a home movie and go pixel by pixel, frame by frame through it, and convert the whole thing to black and white. Here's the problem that puts us in the position of doing the same thing lots of times. Every pixel that we had, what did we have to do? Well, we went to pixel number 1, and we got the RGB values. We took the average, did the fancy math, and replaced the RGB values. What do I do at pixel number 2? Get the RGB values, do some fancy math, replace the values. Pixel 3, same darn thing again. How many times do I have to do that for an image that's 655 by 1920? It's 1.2 million, I think. Yeah. That's a lot of copy-paste, right, if we were going to code this. And then imagine somebody changed the size of your picture. Just how angry that would make you. Well, thankfully, there are ways around this instead of copy and pasting. So let's start somewhere simple. We're going to use loops now to repeat commands. Rather than typing them a dozen times or 1.2 million times, we can just tell the computer that we want it to repeat the command. So, for example, let's try counting to 10. I take a value like x equals 0. How do I, in one line, make x increase by 1? Yeah. I plus plus? X plus plus, right? Or in any language, we could always write x equals x plus 1. And at the end of that step, x would have a value of 1 in it. Now, if I wanted to increment x again, what would I do? Same thing, right? So copy paste this code, x equals x plus 1 again, and now there's a value of 2 sitting in x. And if I copy paste that again, x would be 3, 4, and if I copy paste this enough times, the value sitting in x would be equal to 10. How many times did I do this? Well, 10 times. There are my steps 0 through 9 to get you there. And if I wanted to count to 11, I'd have to paste one more. And if I wanted to count to 4, I'd have to paste a whole bunch less, right? Let's do this using a loop. The way the loop works, this is a for loop. We start with x equals 0. We say I want you to take on every value from 0 to 9 in order. That's what for I 0 to 9 means. Repeat this command x equals x plus 1 that many times. So the first time we come into the loop, x is equal to 0 and I is equal to 0. X equals x plus 1 stores a value of 1 in x, and that's it the first time we hit this end. We come back up here, and I is now equal to 1. X is now, starts at 1, so we got 1 plus 1 is equal to 1 plus 1 is still equal to 2. So I is equal to 1 at the end of the second step, and X is equal to 2. And we just keep repeating this. I is 2, X is 3, I is 3, X is 4, so on and so forth. And when I is finally equal to 9, this thing gives up. That's a for loop. The other way that we could do this is with a thing called a while loop. While uses a condition to check. So you see we don't need I anymore. I say X is equal to 0, and as long as X is less than 10, add another value to X and keep going. What's the danger of a while loop? What's that? Back here, yeah. I'm sorry? It could go an infinite number of times. Does anybody know the mailing address of Apple? Yeah. One infinite loop in Cupertino, California. So what we need to make sure to prevent that is that somehow the code inside this loop can make this statement true. So let's try this out. The first time through, X is equal to 0. Is X less than 10? How about the second time through? X is now equal to 1. X is now equal to 2. Still less than 10. I go through again. What's X going to be equal to? 3. Is that less than 10? And so on and so forth until eventually we get to a point where X is equal to 10. It throws a false, and this thing stops. So, before I let you out of here, I have a couple of exercises for you that will get you ready for what we're going to do on Friday. So here's my question. What's the value of X at the end of this? Take something out, write it down. Your ticket out of here is a piece of paper with this code written on it. Yeah. Yeah. You figured it out in your head? Nice. The values. Just want to check real quick. Oh, perfect, cool. What do you think? No. The values of I and X, and that's the idea. Not right. Nice. You got it. Yeah.
Make sure you write down each values.
Hello. Let's unpack this real quick before we get out of here. How'd you do it? I'm going to put you on the spot. How'd you do it? Yeah? I'm sorry? 5,040. Did anybody else get 5,040? Score. So the strategy for this, the strategy for thinking through these loops, the people that got this, I saw them all do this. They made this table. And every time you hit the end, write down the value of I and x. So the first time through, what's I equal to? Okay, so I is going to be 0, and x is going to be equal to the original value of x, 1, plus, what's x times I in that case? 0. So we got 0 and 1. The next time through, what's I equal to? 1. And so now we've got 1 plus, what's x times I now? 1. It's 1 times 1. So that gives us a value of 2 for x. And if we go through a third time, we'd have I is equal to 2, x is equal to 2, so we've got 2 plus 2 times 2. What's that? 6. And eventually we get to the last one, 50/40. If this didn't work for you, talk to your team lead, get this unpacked. Friday, let me just get to the to-do list here for you. Here we go. Go back. You should be done with JavaScript on Monday. You should find us on social media because you will find hints that will save you time on Friday. And lastly, you should come get some help. Have a nice day.
You guys started letting us know who your tailor is on social media.
Oh, yeah? Hey, thanks, bro. How you doing?
Excellent. I was able to catch one.
Fabulous. Did you get a chance to meet
Mr. White, I did.
Great?
Great. Wasn't able to.